In this session, we shall discuss about row echelon form of a matrix, reduced row echelon form of the matrix, rank definition with respect to the echelon form, and equivalent matrices. What is row echelon form of a matrix? A matrix is said to be in row echelon form or echelon form if the number of zeros preceding the leading entry of a row increases row by row until 0 rows remain. What do you mean by a leading entry? Leading entry represents the first non-zero entry of a row. In other words, a matrix is said to be in row echelon form or echelon form if all the entries below the leading entries are zeros and number of zeros appearing before the leading entry is greater than that in the previous row. Here are a few examples. Let us look at the first example. Let us check whether this particular example represents or satisfies all the properties of echelon form of a matrix. So first of all, let us check whether all the entries below the leading entry are zeros. In the first row, the leading entry is 1. Leading entry is the first non-zero entry. In the second row, that is 0756, the leading entry is 7. In the third row, the leading entry is 1. And all the entries below this leading entries are zeros. We shall now check whether the number of zeros appearing before the leading entry is greater than that in the previous row. Since 1 is the leading entry in the first row and there is no 0 appearing before 1, so the number of zeros appearing before the leading entry here is 0 itself. And number of zeros appearing before 7 is 1, 0. Number of zeros appearing before 1 here is 3. So there are 3 zeros appearing before the leading entry in the third row, which is greater than the number of zeros appearing before the leading entry in the second row, which satisfies all the properties of echelon form of a matrix. So matrix which is mentioned in example 1 is in echelon form. Coming to the second example, we shall now check whether this particular matrix satisfies all the properties of echelon form of a matrix. The number of zeros appearing before the leading entry. So the leading entry in the first row is 1. So the number of zeros appearing before 1 is 2. Number of zeros appearing before the leading entry in the second row. The leading entry in the second row is 3 and number of zeros before 3 is 1, which is lesser than that in the first row, which is lesser than that in the first row. This does not satisfy the property of echelon form of the matrix. So this particular matrix is not in echelon form. Coming to the third example. This particular matrix, let us check whether all the entries below the leading entry are zeros. So this is the leading entry in my first row and all the entries below this leading entry is 0. This is the leading entry in the second row and all the entries below the leading entry is 0. This is the leading entry in the third row and all the entries below -4 is 0. This is the leading entry in the fourth row and the entry below 2 is also 0. We shall also check the number of zeros appearing before the leading entry is greater than that in the previous row. So which means it satisfies the second condition also. That is, there is 1 0 before 1, there are 2 zeros before -4, 3 zeros before 2, and the last row has a 0 row. 0 row is a row in which all the elements are zeros. So in echelon form of the matrix, 0 rows must always appear at the end. So that satisfies all the properties of echelon form of the matrix. Hence, the example 3 is also in echelon form of the matrix. So examples 1 and 3 are in echelon form, whereas example 2 is not in echelon form. Coming to reduced row echelon form. There is a minor difference between reduced row echelon form and echelon form. A matrix is said to be in reduced row echelon form or RREF. RREF stands for reduced row echelon form if the matrix is in row echelon form and the leading entry, that is the first non-zero entry in each row, must be unity. Unity in the sense 1. The leading entry in each row must be 1 and it should be the only non-zero entry in its column. In other words, all the elements above as well as below the leading entry must be zeros. In echelon form of the matrix, all the entries only below the leading entry were zeros. But here in reduced row echelon form, all the entries above as well as below the leading entry are zeros. And the leading entry must always be 1 in reduced row echelon form. Let us look at a few examples. Let us look at example 1. So the best example for a reduced row echelon form of a matrix is the identity matrix of order 3 cross 3. So identity matrix of order 3 cross 3, you can observe the leading entry in each row is 1 and all the entries above and below the leading entry are zeros. So identity matrix is the best example for RREF. So let us discuss now about the first example. The leading entry should always be 1, so it's true, and all the entries above and below the leading entry are zeros, that is also true. So this particular example is in RREF. Coming to the second example, the leading entry in each row is 1, which is true. All the entries above and below the leading entry must be zeros. So let us check that. So below this leading entry it's zeros and above and below it's also 0. Whereas here we have a non-zero element -1 above the leading entry 1. So according to the second property here, the leading entry in each row must be unity. So that's correct, that's true. And it is the only non-zero entry in its column. So in this particular column, 1 is not the only non-zero entry in the column. So you have -1 as well. If this would have been 0 instead of 1, then it would be in RREF. But since it is -1, it's not in RREF. Coming to the third example, we shall check whether the leading entry is 1. It's true. And always the 0 rows must be at the bottom. That is also true. So 0 rows, if at all it appears, must be placed at the bottom. Now all the entries below the leading entries are zeros. So this is our leading entry. So all the entries below 1 is 0. So this is not our leading entry. So we need not check this. This is our leading entry in the second row. So it's above and below 1, it is 0. It's true. So this satisfies all the properties of RREF. So examples 1 and 3 are in RREF, whereas 2 is not in RREF. Coming to rank of a matrix with respect to echelon form, when a given matrix is reduced to echelon form or reduced row echelon form, that is RREF, by using the elementary row operations or row transformations. The number of non-zero rows in the echelon form gives you the rank of the matrix. Given a matrix, we can reduce that matrix to echelon form or reduced row echelon form by using elementary row operations. The resultant matrix which we obtain must be either in row echelon form or RREF. So the number of non-zero rows in the echelon form gives us the rank of the matrix. So in this example, this particular example is in row echelon form. It's in row echelon form. The number of non-zero rows in this particular matrix is 3. So a zero row is a row which has all the elements as 0. So you have a non-zero element, you have 3 non-zero elements, you have 2 non-zero elements. So all the 3 rows are non-zero. So the rank of this matrix is 3. Coming to the second example, you have a 0 row at the bottom, and this particular matrix, right, is in RREF. So either REF, that is row echelon form, or RREF, the number of non-zero rows gives you the rank. So you have 2 non-zero rows, so the rank is 2. Coming to equivalent matrices. When do you say the matrices are equivalent? 2 matrices are said to be equivalent if one of these can be obtained by applying a finite number of successive elementary row or column transformations to the other, or if they have the same rank. For example, you have 2 matrices, matrix A and matrix B. So matrix A has all the elements which is equal to 1. It's a 3 cross 3 matrix. So matrix B has the first row as the elements 1 and the remaining 2 rows are completely 0. These 2 rows are equivalent matrices since I can obtain the matrix B from matrix A by applying the row transformations R2 minus R1 and R3 minus R1. So this is our second row. This is our third row in the matrix A. When I subtract the second row with the first row, all the elements become 0. And when I subtract the third row of the matrix A with the first row, all the elements again become 0. So this is nothing but our matrix B. So I have obtained the matrix B from matrix A by applying elementary row operations in matrix A. And equivalently, you can also say that both these matrices are of the same rank. Rank is the number of non-zero rows. So in both the matrices have the same rank, which is equal to 1. Of course, I can reduce this matrix A to echelon form, right? So this is what is the echelon form of the matrix. And the number of non-zero rows is only 1 because the last 2 rows are completely 0. So both the matrices A and B have the same rank. Hence, they are called as equivalent matrices. In the next session, we shall discuss a few examples of reducing a matrix to echelon form and RREF, and hence obtaining its rank. Thank you.